Okay, students, today I am going to take lecture number 3 in digital image processing. So, next topic is sampling and quantization, and after that we will also discuss about the image sensing technique. So, in image sensing technique, we will use the concept of sampling and quantization. So, we will illustrate one by one here. So, we will start from sampling and quantization. Most images are continuous in nature. So, we already know that image is a two-dimensional function. So, two-dimensional function is the image, and the basic nature of the image is it is the continuous in nature. So, most system in nature operates in continuous time. So, computer handles discrete data. So, computer does not handles the continuous nature of signal. So, it handles the discrete data. So, in order to handle the data that is handled by the computer system, so we need to input the signals in the discrete form. So, in order to retrieve the signals in the discrete form, we will carry out here sampling and quantization. So, to store or transmit or manipulate images, it first must be digitized. So, basic essence of sampling and quantization is mentioned here. In order to store, transmit or manipulate the images, they must first be digitized. So, in order to, if you want to store the images, if you want to transmit into the networks, and if you want to manipulate the images, first of all we need to have the image that is the digital image. So, that is why we need to digitize the images, and for that we can carry out sampling and quantization. So, sampling and quantization is the way to achieve an image which is continuous in nature to in the digital form, that is the digital image. So, in continuation to sampling and quantization, the concept of sampling and quantization is mentioned here. Any natural images is continuous 2D function with respect to the x and y coordinates, and also its in its amplitude. So, in image have the two-dimensional, already we know that is a two-dimensional function which having some amplitude and magnitude value and coordinate value. So, coordinate value are represented with the help of x and y values, and amplitude value are represented with the help of the f, that is the mathematical significance of images is defined as f x y. So, f is the amplitude and x and y are the coordinate of the particular pixels or particular images. So, digitizing the coordinate value is called the sampling. So, if we have the digital images of the form like fxy, so fxy will be the significance of the images like fxy. So, f is the nothing, it is the amplitude value. So, it is defined to be as amplitude value, and xy is to be defined to be as coordinate value. So, this is the coordinate representation of the pixel or coordinate representation of images. So, if we see here, there are two basic quantity. This is the coordinate value and another one is the amplitude value. So, while digitizing this coordinate value, digitizing this coordinate value is called the sampling, and digitizing this amplitude value, digitizing this coordinate value is called the sampling, and digitizing this amplitude value is called the quantization. So, if we are going to digitize the coordinate value, that is xy, so this is the called the sampling, and while digitizing the amplitude value, that is called treated as f, that is termed as the quantization. So, concept of sampling and quantization is very clear here. If you are going to convert the coordinate value into the digital form, so this is called the sampling, and while digitizing the amplitude value, that is called the quantization, that is f. So, concept of sampling and quantization can be better understood by taking this example. So, first of all, this is the actual element, this is the actual object for which image we are interested in taking the image. So, this is the basic object, in which or we can say this is the image that we have taken as an example to understand the concept of the sampling and quantization. So this is the image. So in this image, we are drawing a line from point A to the point B. We are drawing a line from point A to the point B. So with the help of this particular line, which is ranging from point A to the point B, we will understand the concept of sampling and quantization. So if we will see here, this is point A is the lying outside the object. So this is the bright area where this particular point A is located. So brightness represents the highest point, and while darkness represents this is the difference between 0 and 1. So this is the white pixel, and this is the black pixel. So white pixels will always be high, level of white pixels will be always high in comparison to black pixels. So that's why this particular point A is located outside of the object, and this particular point has been shown as the highest point of the representation in the case of continuous signal. So this is the continuous signal representation of this particular line AB. So this is the starting point, which is lying outside the object. That's why it is at the highest point. But if we are going to enter this particular object or this particular scene element, then this is one of the darkest point. So we will go to the lowest point, and after this particular point, the value of gray label is decreasing. That means darkness is decreasing and whiteness is increasing. So that's why this particular point has moved from this point to this point. That's because this is the darkest point. And again this from up to this darkest point, there is the gray label value which is shown by this particular point. So this is the highest point where this particular gray label value is shown here, and this after that again the darkness is increasing. That's why it is also falling down. Then after that, this particular B point is outside of the image, just like point A. So this will move up to the highest point. This is the highest gray label, that is the white label. So this is the analog representation of this particular line AB. After that, we are going to describe this coordinate value. This is called the sampling. So we sampled here each and every points, just like a square shape symbol. This is representing the basically representing the coordinate value. This is again representing the coordinate value. Again after that, each and every point has been represented as the coordinate value, and at the same times the gray amplitude is also has been encoded in the form of increasing label of gray label. So this is the darkest point where the value of which is at the lowest level, and this is the highest point where it is achieving the highest gray label, that is white. So amplitude value is ranging from darkest level to brightest level, that is the brightest level is the white color. So this is the representation of amplitude while in varying degree of resolutions, and this is the representation of the coordinate value in a varying degree of value of x and y. So this is called the sampling and quantization, and finally that has been represented as in this way. This is represent the point A. This is the variation of gray labels, and this is the different value of this is the different variation of the amplitude, that is also called the gray label, and this is the variation of coordinate value. These are the representation of coordinate value, and this one is the representation of f that has been shown here, because image is represented by symbol f x y. So digitizing this x y coordinate value is called the sampling. This is called the sampling, and digitizing this particular f value, amplitude value, this is called the quantization. So some concept of sampling and quantization is very clear, can be illustrated very easy way with the help of this particular scene element, and by drawing a line from point A to the point B, and after that we are representing this line AB in the continuous analog signal, and this analog signal has been sampled in the coordinate value, and this is the coordinate representation of the line AB, and then again it is quantized at different value of gray level. So this is the sampling and quantization, and finally that has been represented by with the help of the varying degree of resolutions and varying degree of the coordinate value. So this is the basic concept of the sampling and quantization. Then after that, this is the representation, continuous representation. This is the digital representation of the image. So this is the difference between the continuous to digital image that has been shown in the screen. So continuous image projected onto a sensor array, result of image sampling and quantization. So this is the digital image. This is the basic image, continuous image. So while talking about the image sensing techniques, so an image may be defined as two-dimensional function fxy. So while x and y are a spatial coordinate, an amplitude of f at any pair of coordinate is called the intensity or gray level of the image. And most of the digital images are generated by the combination of illumination, that means the energy falling on of the object, that is called the source of energy, and the reflection or absorption of energy from that source by the element of the scene being imaged. So image is always represented by mathematical quantity, that is represented as here fxy, where x and y are the spatial coordinates, and amplitude of f at any pair of coordinate is called the intensity or gray level of the image. And most of the digital images are generated by the combination of an illumination energy, that means source of energy that just like a sun, and the reflection or absorption of the energy from the source by the elements of the scene being imaged. So this is the basic fundamental of the image sensing, and how the formation of image is done, and how the image formation is carried out. So this particular diagram shows the sensing element, basic structure of the sensing element. So there are three kind of the sensor which is used to sense the image element, which is used to carried out the capturing of the image. So in this particular diagram, first one is there are three type of sensor. This is the first sensor, and this one is the second type of sensor, and this one is the third type of sensor. So out of these three type of models, first one is called the single sensor, second one is called the line sensor, and third one is called the array sensor or CCD, that is also termed as the charged coupled device. So these three type of image sensing elements can be used to sense the images. So first one is the basic model of the sensor, that is called the single sensor. So out of this here, the sensing material which is in the form of liquid, the sun energy or electrical energy is included here. Then there is the filter, and there is the power in, which is uses electric source. So housing this is the element where this particular formation of this sensor is formed. So this is the voltage wave form out in the form of signals. So this is the single sensor which is used for image capturing, and another one is this line sensor, which is the in the form of line. So this is the second category of the sensor, and this is the array sensor, which is also used for the sensing of the images. So while we will explain here one by one. So image sensing, we combine a single sensor with motion to generate 2D images, because image is a two-dimensional function. So in order to sense the images, we have the sensor where the film is labeled here. So this will always keep rotating at this time. So this particular portion has the linear motion out of this in a linear way. That's why it is also called the linear sensor. So linear motion, one image line out per increment of rotation, and full linear displacement of sensor from left to right. So these particular portions keep moving from left to right and from left to right again and again. So in this way, this will captures the on the whole film element, and the image is to be created, that is called the single sensor. And another one is this is the basic structure of image formation model, that how image is captured and how image is being sensed by natural way. So we have the natural source of energy, that is the sun. Sun is the natural source of energy, we all know. So this is the illumination energy source, which is energy of the sun is falling down on the object, that is called the seen element. So here we have the imaging system. This imaging system could be a camera, this could be a sensor, this could be any kind of device which is able to capture the image. So this imaging system is focusing on this particular scene element, and this scene element is visible just because of the energy incident on the object, and some energy is reflected by this object, and this imaging system is capturing this particular image of this scene element. Then after that, this particular scene element image has been created on the image plane. If image is not digitized, if our image is not digitized, then in order to convert the image into digital image, we will digitize the image by using sampling and quantization. So we will again get here output as the digital image. This is the example of digital image acquisition process. Sorry. So energy elimination source is this one is the energy elimination source. This one is the scene element. This one is the imaging system, which is capturing the image of the scene element, and then after that we are creating the image of the scene element on the image plane. If our image is not in the digital form, then we will convert the image into the digital image. This is the natural way of formation of images, and how image is carried out, and how the formation of image is carried out. So after that, we will carried out the sampling and quantization if the image is not in digital form. So in this way, we will capture the we will convert the image into the digital image. Then this is the again sampling concept of sampling and quantization is shown here. Again, that how this is the analog signal which is taken as input. Then after that we perform the sampling. Then after that quantization. Then encoding is to be carried out. And this encoding is nothing. This is the digital discrete representation of data, that is called the binary signal. So binary signal is the discrete data on which our computer system works. So in order to process the image, we need to have the image as the digital image. So this is the digital representation of the data images, that is the sequence of binary instruction, that is 1010. So this is the basic way of the image formation model, that how sensing elements carried out the formation of the images with the help of the sensor or by using the sensing element. So we'll see here sampling how is to be carried out. In this case, the coordinates are sampled with respect to the discrete interval of x and y value. So this is the different discrete interval of value of x and y, and how the according to value of x and y, the points are scanned over the this plane. So this is the here is the example of where we are sampling the value of the images at the nodes of a regular grid on the image plane. That is the natural phenomena, that is how it used to be carried out. So here pixel or picture element at ij is the image intensity value at grid point indexed by the integer coordinate ij. So ij represents the coordinate value. So this is the analog signal. Again, analog signal representation of three different type of sampling methods. First one is the ideal sampling, second one is the natural sampling, and third one is the flat sampling. So this is the different representation and different type of representation of sampling and how it is to be carried out. So first one is the ideal sampling, second one is the natural sampling, and third one is the flat top sampling. So this is the different way of representation of sampling methods. Another one is the quantization process. So quantization in signal processing system is analog to digital conversion, and this is the way how it is to be carried out. Here signal is taken as input, then sampler works, then after that quantization converts in encoding form. This is the encoding, this is the binary instruction 1011 like that. So this is the discrete signal, that how that it is to be converted into the digital form. So this is again digital to analog converter that decodes this particular binary instruction into the continuous data, a continuous signal. So quantization in signal processing system in analog to digital conversion, that transform coding and decoding. So image quantization is a discrete continuous pixel value into discrete number, and color resolutions, color depth value labels are also matters in this case. Number of colors or gray labels are number of bits representing each pixel value. So number of colors or resolution is what, color depth and labels is what, that is the number of colors or gray labels to represent an image. Number of bits representing each pixel value and number of colors or gray label is given by NC. So sorry, NC is equal to 2 power B. So number of colors needed to represent an image, that is equal to 2 power B. B is the number of bits to represent image, and this is the representation of darkest to brightness level, that how the value is changing from the origin to the highest value, that is the brightest level. So that is also to be defined as L minus 1. So this is the highest value, and representation of quantization with the help of the light in respect to the light intensity value, there is quantization level is shown here. So light intensity value is shown in as x-axis, and y-axis quantization level is shown. This is 0, 1, 2, NC minus 2, NC minus 1 is representing the quantization level, that is number of colors needed to represent an image. Number of colors needed to represent an image. So that is the quantization level. So this is the basic representation of the images by using the different level of bits. So first one images has 8 bit per pixel, so it is more visual, which is more clear. Then after that we are decreasing the number of bits per pixel, so density of pixel is decreasing here. In this case, if the number of pixels is decreasing, then quality of the image is also degrading. So the quality of the image is degraded in second case. Then after that, if the number of pixels, number of bits per pixel is again decreased, that is 2 bits per pixel, then image again quality of the image is degraded. So this is the way how the quality of the image depends on the particular bits level. So if the density of the pixels is density of number of bits per pixel is more, then quality of the image is also very clear. If the number of bits per pixel is decreasing, then then in this case quality of the image will also be decreased. So this is the effect of quantization level, that how value will be ranging in different cases, 256 levels, and after that there is image of 128 levels. Then after that there is image of 64 levels, and after that there is image of the 32 levels. So in this, if we compare these all these 4 images, we can see that in the very first case this particular clock is visible, this particular clock is visible. Then in this case this particular clock is not so visible as per compared to first case. Then again this visibility is decreasing, this visibility is decreasing along with the particular image element, that is this particular structure. So the quality with the variation of the level of number of bits value, the quality of the image is also going to decrease. So this is the impact of the quantization levels with respect to the number of bits value. So this is again representation of different labels with respect to number of bits. So in this image, it is to see false contour, that is 4 labels. So again here this particular clock is not showing clear, and in very fourth case it is invisible. So this is the impact of how the values and the quality of the image gets degraded or increases with respect to the number of bits level. So this is the representation of sampling and quantization with respect to time and the gray level value. And this is variation of different gray level value with respect to the different time interval. And again, this is the simple illustration of sampling and quantization, how this is to be carried out. Sampling and quantization of analog signal. So this is the amplitude continuous, time continuous signal. then if we are perform the sampling to this particular signal, then this is the amplitude continuous and time discrete time intervals representation of the this continuous signal. This is called the sampling, where each and every coordinate have been sampled with respect to the x and y coordinate value, and after that we are again quantizing it to the with respect to amplitude value. So this is the different amplitude representation of the images. So this is the called the quantization. So sampling and quantization can be listed here. This example has been already discussed with respect to the this line AB, and this line AB is line A is point A is outside of the image. So this is the brightest portion. So it will be represented by the highest point. So highest point it will be represented by point A. This will be the highest bright level. Then after that we are going to the entering into the image. Then image has the one of the darkest level. So this darkest point will be shown here with respect to this point. And after that, if we move from this point to this point, the gray level is brightness is increasing. So the value will be moving upward direction. Then after that, after this point, we again the value of brightness is decreasing. So we'll move to the downward direction. If we go outside of up to the point B, then again this point B will be the highest point because it is outside of the image, and it is the one of the highest point available here. So will be represented by sampling and quantization, and this is the simple illustration of coordinate value. This is the quantization level. So this is the final image. This is the how the image element has been converted into the digital image, and this is the natural source of formation of images where eye system our works. So this is our palm tree, whose height is 15 meters, and this is the human eyes, human visual system which is working here. So this human visual system is shown here. This particular circle represents the formation representation of eye. So this particular eye represents that particular observer is available at here. So this is observing this particular palm tree whose height is 15 meters and which is available at a distance of 100 meters. So at this point the image is going to create. So distance from this point to this point is 100 meters, and diameter of this particular eyes is 17 mm, and at this point the image is going to create in this way. This is the formation of image on the eyes. So according to Pythagoras theorem, if you want to compute the height of this particular image, so in this case we will calculate with the help of the Pythagoras theorem. So by applying the Pythagoras theorem, height upon distance, so this is the height, this is the distance. So height upon distance is equal to height upon distance. So height of the, if we suppose that height of this image is h, then h upon distance, this is 17 mm, so h upon 17. So we can calculate the value of h is equal to 17 into 50 divided by 100. So h is the height of the image created in the eye. So in this way we will be able to create the height of the image. So this is again natural formation of imaging system is shown here. This is the image formation model. Mathematically, a digital image can be considered as discrete function. This is the fxy. So d square is defined as I. So this is the mathematical model we can compose here. So value of d will be ranging from 0 to n minus 1, and value of intensity will be ranging from 0 to L minus 1. This is the highest intensity level, which is belonging to d square. So here d square is a finite domain, which is called the spatial domain of the image function, and I is a codomain of the image function. So image formation, when image fxy, x and y is spatial coordinate generated from a physical process, its value are proportional to energy radiated by physical source by electromagnetic waves. So this is can be defined as 0 less than fxy less than equal to infinity. So 0 can be taken as if day is not sunny. If day is sunny, then sun can be a infinite source of amount of energy. So that must be non-zero and finite. So value of fxy will be ranging from 0 to infinity, because our here the light source has been taken as sun. So sun is the infinite source of energy. That's why this amount infinity has been taken out. So fxy is characterized by the amount of source illumination incident on the image being viewed, and the amount of illumination reflected by the particular object. So fxy can be treated as ixy into rxy, where the value of ixy will be ranging from 0 to infinity, and value of reflectance will be ranging from 0 to 1, where 0 denotes the total absorption of energy and 1 denotes the total reflectance of energy. So this is how values are correlated here. And then again, this can be formed in the form of interval between L min to L max. So L min represents the lowest interval, that is 0, and L max denotes the highest value of intensity, that is the L max. So this can be defined as L min minus L min, L max minus L min. So while substituting the L min at both sides, we will form the this particular interval, that is called 0 to L minus 1. So 0 corresponds to black and L minus 1 corresponds to white. So we say that grayscale contains L gray levels. So there could be L gray levels. So in this particular lectures, we will discuss up to this image formation model, and in subsequent lectures we will talk about the more interesting topics and more interesting facts about the image processing. Thank you.